Welcome to The Explainer. Today, we're going on a deep dive, way down into the hidden world of matter, to uncover the secret life of the particles that make up, well, literally everything. So let's kick things off with a puzzle from everyday life. You know how it is. The amazing smell of something hot and sizzling can find you from all the way across the house. But for cold food, you pretty much have to stick your nose right in it. Why is that? Well, the answer isn't about our noses, it's about the invisible dance of particles. And by the time we're done here, you're going to get it completely. To crack that puzzle, we've got to start with the absolute basics. Everything you can see, everything you can touch, even the air you're breathing right now, it's all made of the same fundamental stuff. And that stuff is called matter. And you know, the scientific definition is beautifully simple. If it has mass, if it has some weight to it, and it takes up space, guess what? It's matter. A giant star, a tiny grain of sand, a single drop of water, it's all part of the same club. So this led to a huge debate for centuries. If you could zoom in on a piece of wood, would it just be a solid, unbroken block of woodness? Or is it made of tiny individual bits, kind of like a sandy beach is made up of countless grains of sand? Well, it turns out a couple of super simple experiments give us the answer. Okay, time to put on our microscopic goggles. We're zooming way, way in to see what this matter stuff is really doing. Okay, think about this for a second. You do this all the time. You stir salt into water. The salt vanishes, but the water level doesn't go up. If water were a solid block, where could the salt possibly go? This tells us something incredible. The tiny salt particles must be slipping into invisible gaps that already exist between the water particles. And this experiment, this one really shows just how unbelievably tiny these particles are. For just a couple of little crystals to turn an entire beaker of water purple, each one of those crystals has to be made of millions, and I mean millions, of even smaller particles that break off and spread out. So here's the big takeaway. One tiny thing that you can see, like a crystal of salt, is actually made of millions of invisible particles. Matter isn't one solid thing at all. It's a collection of countless, tiny, tiny pieces. So, from just those simple observations, scientists figured out 3 fundamental rules for all particles. 1, there's empty space between them. 2, they are always, always moving. And 3, they have a force of attraction between them. These 3 rules, they're the key to understanding, well, pretty much everything. Now, let's see how those rules actually play out in the real world. Because how these particles move and how strongly they attract each other, that's what gives us the 3 states of matter we all know: solid, liquid, and gas. And this table here, this is where it all just clicks into place. In a solid, see, the particles are locked in tight, just vibrating back and forth. In a liquid, they've got enough energy to break free a bit and slide past one another. That's why liquids can flow. And in a gas, oh man, they're moving so fast and are so far apart, they just go wild and expand to fill any container you put them in. And there it is, the solution to our original puzzle. All that constant wiggling and moving around is a type of energy called kinetic energy. And when you add heat, when you raise the temperature, you're just giving those particles more kinetic energy. You're making them move faster and spread out more. The particles from that hot, sizzling food have a ton of energy, so they literally race through the air right to your nose. The particles from the cold food, they're just kind of slow and lazy, and they don't travel nearly as far. Simple as that. Okay, so we've got it. Heating particles makes them zoom around faster. And that's exactly how matter changes state, how solid ice turns into liquid water, and then that water turns into steam. But there's a really strange little secret hidden in that process. So check this out. If you were to track the temperature of a block of ice while you heat it, you'd see something really weird. The temperature goes up, hits 0 degrees, and then it just stops. It stays flat at 0 degrees until all the ice is melted. Then it starts climbing again, hits 100 degrees, and boom, it goes flat again until all the water has boiled away. You're still adding heat, but the thermometer isn't moving. What is going on? Seriously, where is all that energy going? It can't just be disappearing, right? Physics doesn't work that way. The answer to this reveals one of the coolest concepts in the whole field. It's called latent heat. The word latent literally means hidden. So during a state change, all that heat energy you're adding isn't being used to make the particles move faster anymore. Nope, it's being used for one specific job: to break the forces of attraction, to snap the bonds holding the particles together so they can change their state. It's not get hotter energy, it's break free energy.
But here's the thing. Changing from a liquid to a gas doesn't always require all the drama of boiling. There's a much quieter, gentler way it happens, and it's a process your own body uses every single day to keep you from overheating.
In that process is evaporation. Now, it's totally different from boiling. It can happen at any temperature, and, this is key, it only happens at the very surface of the liquid. You can think of it like individual, super energetic particles making a run for it and escaping from the surface into the air.
And you've seen the factors that affect this a million times in your own life. Why do clothes dry faster when you spread them out? More surface area. Why do they dry faster on a hot, windy, dry day? Well, all of those things help more of those surface particles make their great escape into the air.
Now, here's the magic trick. Remember how only the fastest, most energetic particles escape? Well, when they leave, they take all their heat energy with them. And what does that do to the particles left behind? It lowers their average energy. The liquid that's left over actually gets cooler. Evaporation is basically nature's air conditioner. And that's exactly what you feel when you get acetone or perfume on your skin. That sudden, chilly feeling, that's the liquid evaporating and literally stealing heat right from your skin to do it. And that's precisely how sweating works. Your body pushes out sweat so that as it evaporates, it can carry away your body heat and cool you down. It's a brilliant bit of biological engineering. And there you have it, our journey into the secret life of matter. We've seen that everything around us is just a collection of tiny, jiggling particles. How fast they move tells us if something's a solid, a liquid, or a gas. And it explains everything from why we can smell hot food to why sweating keeps us alive. Which, of course, leaves us with one final mind-bending question to think about.